Hey, folks, Smash is back. And today, that's right, folks, we're going to be going over the, the 2023 Paper 1 for higher maths. Yeah, so exams on the Monday or on the Wednesday, I forgot. But yeah, might as well. I'll stop rambling and I'll actually do something. So, question numero uno. Given that y equals x to the power of 5 over 3 minus 10 over x to the power of 4, find the derivative. Okay, well, I'm going to start by just writing down the equation. Now, we can't take the derivative just yet because we've got this weird fraction on this side. I'm sorry about that for. So what I'm going to do is I'm just going to flip it to make it not awful. So it'll be minus 10 times x to the power of negative 4. Okay, now I've got it into a form that we can actually differentiate. So we're just going to put dy dx. They really make sure to put this in because they get really irritated if you don't. And we're just going to do the regular differential. So remember, times by the power. So you have 5 over 3 times x, but then we take away 1 from the power. So we have x to the power of 2 over 3. And then times by power here, so I channel it with plus 40. Because the negative times negative equals a positive. And then take 1 away from the power, this will be 40 to the negative 5. And there we are. That's actually a full 3 marks. Maths is quite generous, I think, with marks. So, yeah, that's what you need to write. Number 2. P and Q are the points minus 2, 6 and 10, 0. Find the equation of the perpendicular bisector of PQ. Okay, what does that word jargon mean? Well, basically, I'm going to draw a wee graph here. So, P looks like it will be somewhere up there, and then Q would be down here. So I'll just quickly label them, and then we'll have a line drawing between them. So the perpendicular bisector of PQ is that if we found the exact center of this line, let's switch to yellow, and then we found something that's exactly perpendicular to it. So how are we going to do this? Well, what I'm going to do is I'm going to go and find the midpoint of P and Q. So that'll give us this point in the middle here. And then I can calculate the gradient of PQ and figure out what perpendicular would be. And then we have a gradient and a point, so we can calculate the equation. So let's get cracking. I'm going to start by working out the gradient of PQ. Equals y over x minus x1. So y is 0, and then it starts at 6. And then 10 minus 2, which gives us a gradient of minus 6 over 12, of which known as minus 1/2. Fantastic. But that's the gradient of this line going down the way. We want the equation of this line going up the way. So I'm going to go and put it through our perpendicular gradient formula, which is this. So we're going to put it there, and then it's something with times to make it minus 1. This symbol here, this like upside down T, that means perpendicular. So what do you times minus 1/2 to get 1? Well, you just flip this, the fraction, and change the sign, which will give us 2. Which should be our gradient of this line. And we can check on our wee graph here. Yeah, that makes sense because it's going upwards at a fairly steep rate. So yeah, 2 does make sense within this context. So next, we just need to find out the midpoint of PQ, and then we can work out the equation. So midpoint, I'm going to have to write down the whole bloody formula. I'm a very formula-oriented person, so you're just going to have to cope with me on this one. But essentially what we're going to do is we're going to average out the x and y coordinates and see what we get. So we have 2, and then it goes up to 10. And then we have 6, and then it goes down to 0. So what does this get us? Well, minus 2, that's 10 minus 2, so it's 8. Divide that by 2, we get 4. And and then 6 divided by 2 is 3. So the midpoint is 4, 3. Fantastic. And now we've got all our tools. So we can plug it into our gradient formula. B is 3. M is 2. A is 4. I'll multiply out the brackets on the right. 2x minus 8. And then I'm going to add 3 to both sides. So cancel out the 3 on this one. And will give us minus 5. So y equals 2x minus 5. And there we are. Done and dusted. Next up we have solve log base 5x minus log base 5 3 equals 2. This will be a nice juicy log one. Logs always seem more complicated than they actually are, but I trust they're not actually going to be that difficult. So remember, when you subtract logs, you can actually just replace them with one log. You can divide the bits in the middle. So we can go ahead and straight up write, say log 5 x over 3 equals 2. And then since we have one log on this side, we can go and swap it over. So that means x over 3 will equal 5 to the power of 2. And then we can go and compute this. So x over 3, well, what's 5 to the power of 2? That's 25. And then if we times 3, both sides by 3, we have just plain x. And then 3 times 25 is 75. Solved. We'll move on to 4. The diagram shows two right-angled triangles with angles P and Q as marked. Determine the value of cos P and cos Q. So these are nice one markers, so we don't actually need to write much. But remember that cos in this context would be equal to it's cat, so cat over, so it's A over H, so adjacent over hypotenuse. Therefore, cos P would equal, we go over here, we're like, okay, well, we know the hypotenuse, but we don't know the adjacent. But these are right angled triangles, right? So that means we can actually work out what side there are. So in this case, we want to figure out this distance here, and I'll quickly open this up in the actually garbage annotation software I've got. But here we can go and say, well, c squared equals a squared plus b squared, right? We know c squared is 5. We know one of the sides is 4. So you can figure out b, because 25 equals 16 plus b squared. So take it away from each other, we get 9 equals b squared. So b equals 3 technically. Equals 3. That's not the way you write it though. It technically is minus and positive 3, but we're working with lengths here, so there is no negative lengths. So this one side is 3. And then we'll work out this high side here, just because I know we'll probably have to use it eventually. So the hypotenuse of this side, so remember c squared equals a squared plus b squared, 3 squared plus 6 squared, c squared equals 9 plus 36, which equals 245. So c equals root 45, and then I'll simplify it just because it's going to make the maths slightly easier later on. So I'm going to divide both sides. I'm going to divide this by root 9, which is 3, which leaves us with 3 root 5. Okay, let's go and actually do something else. So cos P, you look over here, we've got adjacent, figure out is 3, and then hypotenuse is 5. Fantastic. And then we'll move on to cos Q. And well, if you look over this side, we see that it's well, that's adjacent on our hypotenuse again, and we figure out this length here is 3 root 5. So it's going to be 3 over 3 root 5. That's way too small for folks to see it. Sorry, folks. Yeah, might just paint it as drawbacks, but we can simplify that. Remember, we can take both 3's, so we can get it with 1 over root 5. And there we go. There's our answers. So then we get to the mathsy part. Well, this was supposed to be okay. I flipped up the things here. Whoops. That was the best of us, eh? This would be I and II. Let's go and figure out B. So it says determine the value of cos P plus Q. So how are we going to do this? Well, remember cos P plus Q. That we can expand it out in our relationship sheets, which are, and I'll just quickly pull up. That's the physics. There we go. So what we can learn here is, well, cos equals cos A plus B would equal cos A times cos B minus sine A sine B. Yeah, the reason this sign is inverted here is because it's the opposite of whatever that sign is. So I'll go and quickly write that out. Not hugely difficult to remember, so I wouldn't worry too much about it. But if any doubt, there's no shame in checking your formula sheet. And as we've already established what cos P and cos Q are, so we can just go and straight up shove that in. So that'd be 3/5 times 1 over root 5. And then minus sine P and sine Q. But we've already established how we can get those. So remember, sine equals so it's opposite over hypotenuse, which means for sine P it would be 4 over 5, and then for sine Q it would be 6 over 3 root 5, which yeah, you could simplify down to 2 over root 5, but we'll, yeah, so we're going to quickly do that then. So you can simplify that to 2 over root 5, and then we can start multiplying. So remember, when you multiply fractions, it's just multiply top and top and then bottom and bottom. This will give us 3 over 5 root 5. 5 does not cancel out the root 5. And then 4 times 2, that's 8. And 5 times root 5, that's again 5 root 5. And whenever you do these kinds of questions, you should find you have the same base, the same denominator, which means you can subtract them. We get minus 5 over 5 root 5. And then, of course, we can divide both sides by 5, giving us minus 1 over root 5 as our final answer. And there we are. Move on to question 5. The equation 2x squared plus 3p minus 2x plus p equals 0 has equal roots. Determine the possible values of p. I'll go and it's only 3 marks. I'm going to quickly write that out. So if it has equal roots, basically what you do there is you say that means that if equal roots, oops, use the discriminant, b squared plus 8 minus 4ac equals 0. And then we can start feeding stuff in here. So b is obviously this function here, or the expression I should say. Minus 4. A is that one. That's 2. And then C is P. So this will have to equal 0 for it to equal actual roots. So then we have to square this. So we start by multiplying the first term by itself. So it gives us 9p squared. And then 3p minus 2, well, that will give it times minus 2. That will give us minus 6p, but we double it because we do it twice. So that would be minus 12p. And then, so I was just double checking my answers there. And then we multiply minus 2 by themselves, which gives us plus 4. We're then going to, option to make me scroll horizontally, I'm actually fuming. We're going to go and sort this out. So minus 4 times 2 times p, that's going to be minus 8p equals 0. We'll then conjugate like terms. And then we have a quadratic expression we can then use to figure out our answers. So this is a bit of an annoying one because we have a huge number at the start, and we won't be able to divide it by 2, so we can't simplify the equation any further. But it's maths, so it's not it's not always easy. So what I'm going to do here is, in my head, I'm going to think, okay, well, I'm going to times these two together, and we'll see why soon. So 9 times 4, that gives us 36. And then we're going to leave this line. So basically what we want to do is we want to find some numbers that add to get minus 20, but multiply to get 36. So the way you do this is you can go through 36 and find its factors. And I've already thought of one, but let's just go through them all just to see. 2 and 18 do look pretty decent. There's a hint for you. So it would be 3 times 12, wouldn't it? And then 4 times 9. And I think that's all of them. 6 times 6. So 36 is a square number, so it actually has an odd number of factors. Because, well, technically it gets us even, but you multiply one of the factors together, so you have an even number of factors if you count a repeating factor. But anyway, enough nonsense. But I've already established 2 and 18 do equal 20. So that's what we're going to start out with. I'll leave a gap here because I'm going to have to do some weird nonsense later for p. But our base values are going to be, we've got a positive thing here and a minus thing here, so it's going to have to be both minus. So that helps us out there. So p2, p minus 18. But of course, then what we need to do is figure out how we're going to sort out this middle number here. So I'm going to look at these factors and see how well they divide. And well, 2 is a prime number, so you can't really divide it by anything apart from itself, and 9 doesn't go well to that. So I'm going to say, 18, that goes into a 9 quite nicely, actually. So I think these factors here, they should be 9 and 1. So if I put 9 here, and 1 would be there, that means I have to divide this by 9. So I'm going to rub it out and replace it with 2. And then you can check to see if this system has worked, because minus 2 minus 2, that's plus 4. And then minus 2, that's minus 18, and then minus 2 again, you get minus 20, and then 9 times p, that's minus p squared. Alright, so that's a lot of nonsense, but basically we've got these two. But remember, we've set this whole thing to 0, so that means what we can say is either 9p minus 2 equals 0, or p minus 2 equals 0. So p minus 2 equals 0, that means p could be 2. Or, if we go down from here, that means 9p could be 2. So that means p could be 2 over 9. And there we go, there's our answer. So p equals 2 and p equals 2 over 9. Whew, that was a bit longer than I was hoping for, but here we are. So, next question, question 6. Find the integral of 2x5 minus 6 root x. Yeah, let's get cracking then, eh? So integrals, say, are very similar to derivatives. They're just in the opposite direction. But the same thing applies. You have to prepare it for integration. Remember your dx's, by the way. I always forget them. So before we do anything, I'm going to go and say 2x 5 minus, well, 6 root x. It's the same as 6x to the half. Remember, roots are the same as fractional powers. And there we go. We can start integrating. So what we're going to do here, remember, it's the opposite of things. So we're going to add 1 to the new power. Excuse me. So we're going to have up to 6, and then we're going to divide by that new power. And same goes for this one. So we add 1 to the power. That will give us 3 over 2 over 3 over 2. Okay, so here we just now, and we need to remember the final ingredient, the one that always misses me that 1 mark, plus c, because this is not a definite integral, it's an indefinite integral, so you have to have this constant that's just kind of sitting around. So then let's go and clean up the equations. So that means we can say, we can divide both sides of this by 2. So that means we have x to the power of 6 over 3. And then we can divide these both sides. When you divide fractions, remember, it's the same as multiplying them, but they're flipped, which means this equals the same as 12 over 3 x to the power of over 2 plus c. And then we can simplify that to 4 x to the 2 plus c. And there's our answer. Right, we'll move on to 7. Evaluate log 2 plus log base 2 1 over 40. So when it ever says evaluate, that just means kind of calculate. And there's only 2 marks, so this one should be fairly simple. So remember when I said that if you take away logs, you're kind of dividing the things in the middle? Well, when you add them, you just multiply them. So that's exactly what we're going to do. So that means this whole thing is the same as log 2 of 5 over 40. Right. So what we're going to do now is I'm going to simplify that fraction. Divide both sides by 5. Therefore gives us 1 over 8. So, how we're going to figure out that from there? Well, what we can say, remember, negative logs, negative powers, right? So if I have x to the minus y, that is the same as 1 over x to the y. Okay? So that means that we can state that minus log, this is not necessary, you can just go off from that. You can say, well, it's the same as minus log 2 of 8. And well, what's log of 8? Well, you can say, well, times 2 by 2 times 2 to get 8. That's 3 2's, so it would be minus 3. Goes 2 to the power 3 is 8. Okay, move on to B. It's only a 1 marker. Given that A is a real number, that's what that symbol means, and that log 8A is negative, states the range of possible values of A. Okay, well, this is going to be a fairly simple one if I reading this correctly. So you can't take logs of negative numbers. So already we can be like, okay, well, it has to be above 0. But also, if it's negative, then it has to be a fraction. You know, like if this was 1 1, then it'd be 0, because log of 1 is 0 of any base. So, and any log higher than that, you'd get a non-zero answer. So that means if it has to be negative, right, then A has to be lower than 1. It's only in this small space here where a is a fraction that the log of it would be negative. And you can see that on the log graph, actually, if I draw this out. Log graph looks something along the lines of that for any log. And you can see it gets closer and closer to 0. It's only when and 1, this point here is always going to be 1. So as soon as it gets below 1, it gets closer and closer to 0, but it never actually reaches it. So you can get closest once, but it gets infinitely close, never exact. Right, we'll move on to 8. A function f is defined on R, the set of real numbers, by fx equals x cubed plus 3x squared minus 9x plus 5. Find the coordinates of the stationary point of f and determine their nature. Okay, so what we're going to do for this one, well, essentially what we're going to do is work out the derivative of this, and then stationary points where the derivative is 0, so we can work out those from that, and then we can use nature tables to determine if they're minimal maximums, and then we can figure that out at the end. So let's go and differentiate this. So I'm going to start by writing the original formula, because that just makes logical sense, let's face it. And I've realised my rubbish log graph might just get in the way, but here we are. Beautiful. Right, let's go and differentiate it. So when you're differentiating using this function thing, you'd actually use this f dash x, not dy, not dx. And then we'll do the same. So remember, times by the original power, and then take away 1. We'll do this from the same here, and then minus 9, and constants disappear. Right, now that we have this, we can say, well, 4 SPs, so stationary points, f dash x equals 0. So 0 equals 3x plus 6x minus 9. And then we can go and work it out from here. So I'm going to make things simpler for myself. Divide everything by 3. That gives us x squared plus 2x minus 3. And well, this 3 doesn't really matter anymore, but I keep it in just for simplicity's sake. Follow along. We can work out the effects from this. So we need a pair of numbers that add together to get 2, but to multiply together to get minus 3. So I'm thinking for this one, what if we use 3 and minus 1? Because, yeah, 3 times minus 1 is minus 3, but 3 plus minus 1 is 2. So let's go and do that. And there we are. We can now see our factors. So x could be minus 3, or it could be 1. Because these two have to, each of these have to be 0. So minus 3 plus 3, that's 0. 1 minus 1, that's also 0. So what can we use all these numbers for? Well, now we know the x coordinates of the stationary points. Now, all we need to do now is work out the y coordinates and also use nature tables to determine the nature. So let's go and do the y one first because it's kind of funny. So y1, what we want to use is use the original equation, which is this beast, minus 9x plus 5. And we're going to just shove our numbers in there. So we have minus 3 and 1. So we're just going to have to do this, we're just going to have to compute this, unfortunately. So remember for this one, cubing a negative number will give you a negative number. It's not like squaring, where it will always give you a positive number, because it's odd. The power's odd, so it won't matter. Right, so we're going to get this out of the way. So minus 3 to the power of 3, that would be minus 27. 3 times minus 3 squared, that's 3 times 9 essentially, which is 27. So these two can cancel each other out. Minus 9 times minus 3, that's going to be another plus 27, and then plus 5. So essentially it would be 32. And next up, we're going to do the same for 1. And I won't bother writing the equation this time. So that'd be 1. 1 should be a bit easier because, well, powers of 1 are always 1. So that's 1 plus 3 minus 9 plus 5. That's 4 minus 9 plus 5. So that should be 0. Cool. Right, and further along horizontally we go. Now we need to work out nature table. So what I'm going to do here, nature table looks something along the lines of this. So we have x at the top, and we know we've got 2 stationary points at -3 and 1. So I'm going to check -3. So I do a bit beforehand. Let's go -4. Then we go to -3, and then we're going to go to -2. And then what we're going to do here is I'm going to put my derivative function. So this is to check how the gradient would is slightly before or after the our stationary point. So yeah, you're going to have to run through this whole bloody differentiating thing again. So it's a bit painful, but we stick to it. So I just write this down here to remind me. So this will output our so if we plug this in, -3, we'll actually get 0. But we're going to put -4 in. +6, -4, -9. So -4 squared, that's 16. So 3 times 16, that's 48. Plus 6 times -4, that's -24. And then we -9 from that. So that would be 24 -9, which is, what is it, 15. But all you need to know is, okay, it's a positive. So that's going to have shape at the bottom here. So that means the graph is going upwards. Now we could plug 3 in, but we've already established it's a stationary point, so it's going to be 0, which means it's not going to be moving. It's going to be moving, but only horizontally. So let's plug -2 in. Yeah, these equations are very calculation heavy. They're way better in calculator because you can just jam them out. But oh well. So 3 times -2 squared. Plus 6, -2, -9. -2 squared is 4, so that means we have 12, and then -12 here because 6 times -2 is -12, then -9, which you can see that cancel out, so we get -9, which means that that is a negative and it will go down. So that means that this point here is a maximum. So you should expect the other one to be a minimum because the original function is a cubic thing. But let's just double check because otherwise the SQA will eat my guts. So I, for some reason, decided not to use a. What you can actually do is I'll just try and fix my mistake now. Is you can actually. Because this is a cubic thing that doesn't have any weird logs or something that would create a discontinuous function, you can actually just go across things. So we know there's a thing at 1, 2 is before 1, so it should give us the same negative positive gradient. And then a bit after 1, we'll pick 2. So we know it goes down, so it shouldn't change sign of gradient between -2 and 1. So we know 1 is 0, so the shape will be cross. And 2 should be, if it's a cubic graph, probably positive. That's what I'm thinking, but let's go and double check to be sure. So let's go and plug 2 in. And then finally we'll be free of the shackles of this question. So that's 12 plus 12 minus 9, that's positive. So it goes up. So that means we can say that this point here is a minimum. So, after you've done all that bloody work, what do you say? Well, you're going to make a weak conclusion. So we're going to say, well, maximum at -3, 32 was it? Yeah. And then minimum at, I do not want to save it to my homework folder. No, I do not. I want to press Control Z. Thank you very much. At 1, 0. Oh! Wow, that really set me for a car ride, wasn't it? So yeah, that's an awful lot of maths for one question, but hey, it's 6 marks, so I mean, what were you expecting it to be easy? So yeah, I'll go and scroll all the way back up, and then we'll continue. The diagram shows the graph of the function fx equals log 3x, where x is above 0. Okay, so the inverse function exists. Thank goodness for that. Oh, imagine if it didn't. On a diagram reactor book, sketch the graph of y equals the inverse graph minus 1. So I'm going to do a wee bit of laziness here, because there should be a diagram in your answer book that allows you to do this. But let's just go and paste this into Microsoft Paint. We pixelated, but what can you do? So when you want to sketch an inverse function, you could actually work out algebraically and be like, oh, what could be the inverse function? Or you could be really lazy, which is what you should do, and figure out and reflect it in 45 degrees. So I'll get my shape here. I can go and make an imaginary line at exactly 45 degrees, and we're going to reflect that. Reflect this graph onto the other side, and that doing that basically does is it just flips the coordinates around. So that means I'm going to have a graph where I'm going to have 0.10 is going to turn into 0, 1, and then 3, 1 is going to turn into 1, 3, which would be like up here or something. I don't know. You don't need to have, the graph doesn't need to be amazing. And then we're going to copy the curve from that side. And I could use some fancy Microsoft Paint magic, but we're going to make our line green just a minute. Anyway, but roughly it would be like that, right? It's not great, but remember, it's getting closer and closer to 0, but it's not. Anyway. So the graph. So this is the inverse function, but it actually wants inverse function minus 1. So what we're going to have to do, unfortunately, is going to take all of these coordinates and subtract 1 by them from them. So I'm going to get rid of my beautiful thing, all my beautiful coordinates. So just remember that kind of like green thing in your head. Actually, no, I'll keep them, and then I'll replace them with a different color. That's probably a smart idea, ain't it? There we go. So let's go and move to yellow. So we're going to move all these down. So the new point is going to be exactly at the origin. And then 1, 3, that's going to move down to like here or something, where it would be 1, 2. And then we're going to have the exact same thing, but it's just going to same kind of style graph. And then remember, as it's approaching 0, it's flattening out against 0. You want to have it so it's kind of flattening out into minus 1 instead. But there we go. So yeah, not the best drawn graph, but as long as you get the coordinates right and they're not insane, they doesn't get the sort of what it looks like. They'll give you the mark. Right, moving on. We got 10. Show that x plus 5 is a factor of that function. And then we got to solve it, which, yeah, 7 marks in all. Oh, terrible. So, well, best get into it then. So 10a, this one's a bit easier. What we're going to do is going to use synthetic division, I believe, where it's this process here. So we're going to have a look at all these numbers that begin at the start of the equation. So nothing's timesing the coefficients, as we call them. So nothing's timesing x to the power of 4, so it's just 1. And then, well, it's plus 3 for the next one. I'm not going to write 3, so. And then minus 7, and then 9, and then minus 30. Okay, and then we're going to have to find factor. So if x plus 5 is a factor, then x equals minus 5 as a root, right? Because this will have to equal 0. So that means if I plug minus 5 in here, we should get 0 because it's a root. So let's going to do that. So 1, 1. If we just write down then 1 there, and then we're going to multiply by minus 5. Add to 3. Okay, well that's minus 2. And then we can repeat the process. So minus 5 times minus 2 is 10. Add it to minus 7, that's 3. So that'll be minus 15. Add that to 9. That would be minus 6 times by minus 5. That gives us positive 30. And you add negative 30. That gives 0. So 0 equals R. So that means that x plus 5 is a root, is a factor. So there we go. That's 2 marks done and dusted. Hence or otherwise show this whole equation. So what we're going to do here is that we've already kind of divided it once, so that means we're going to divide it again and again until we get all the factors. So what we can do here is you can be like, okay, well, x4 plus 3x cubed minus 7x squared plus 9x I'll make that 9 a bit clearer. Minus 30. So I'm going to go and, but we know that if we plug minus 5 in this, this is a factor of that. So we can actually divide it because this remainder down here is the what happens when we divide this. So that means we can say, okay, well, this equals x plus 5 times, so that's 1, 2, 3, 4. So this is going to be x cubed minus 2x squared plus 3x minus 6. This is a cubic term, so we can't strictly factorize it yet. If you want to, unless you want to put out the cubic formulas, which I do not. So we're gonna do it again. Lovely job, ain't that? So I'm gonna put this in. So there's nothing timesing. It's the same numbers here essentially. So 1, 2, minus 2. Sorry, 3 minus 6. And then we're just going to have to find a number that equals 0. So the way you do that is you can often just look at the factors of this number here, minus 6. And I'm going to pick 2, let's say. Because, yeah, 2 goes in 6. Sometimes it's 1, but maybe I know the answers. I wanted to get through this as fast as possible. So 1, 1, but if you don't, you just go and check and see. It's not that difficult to just run through it. So 1, 1. And then we're going to multiply by 2. 2 minus 2 is 0. And the 0 goes over here, so 3. But then 3 times 2 is 6. So that means 0 equals r. So therefore, 2 is a factor. It's a root, I'm afraid, sorry. So that means that x minus 2 is a factor. So we can expand this out again. And then we know that it's now, we reduce to x squared plus 3, and we can solve that, well, attempt to. So I'm looking at this and I'm a bit scared. I don't think I can factorize this. So if you're a bit scared of it and you're not sure you can factorize it, what you can do to prove it is go and use the quadratic formula. Sorry, I'm up to there. So quadratic formula. Alright, so now that you've got the quadratic formula, you're going to plug the numbers in here. So there's no b, so z it's 0 squared minus 4 times a, which is 1, and c is 3. So that's 0 minus 12. And no, it's horrific. A negative discriminant. That means that there's no real roots. So unless you want to pull out some complex numbers, you are going to not be able to divide it. So, so that means you say no. Further real solutions. And that makes sense because remember this whole thing would equal 0, and you're gonna have to you need to find a number that when squared gives you -3. Ooh, and that's banned. So no real numbers there. So that means we just have to go with solutions we've got, which is x equals -5 and x equals 2. And there we go. Oh, these questions really throwing me through. But hey, we're on the last page, and these ones look a bit easier. Cross fingers. Let's go and do 11. Okay, evaluate this integral. And this is a definite integral, so we won't be using plus c. We'll be calculating between two limits. So how are we going to do that? Well, right, so I'm going to write down the integral first. Five sine x minus 3 cos x dx. This looks to be able to be integrated pretty okay. There's nothing weird we need to do. So I'm just going to go and get straight into it and go and integrate it. So when you've got integrating things, I always remember maybe draw a wheel in your relationship sheet, which is going to be sine x. If you differentiate that, you get cos x. If you differentiate that, you get minus sine x. And then if you differentiate that, you get minus cos x, which if you differentiate again, you get sine x. So integrating is going the opposite way. So that means we're actually going to have sine x turn into minus sine x. So that means you have minus 5, minus cos x, sorry. So minus 5 cos x, and then cos x will go backwards to sine x. And then we'll put in our limits. And then what we can do is go and run the numbers. So 5 cos x pi minus 3 sine x pi, sine pi, sorry, and then minus minus 5 cos pi over 2 minus 3 sine pi over 2. Now luckily these pi's are pretty simple, I believe, so what we just need to do here is remember the cos and sine graphs. So I'll just go and quickly draw them out. So this is the cos graph, and then this is the sine graph, and at 90 degrees that's this on the sine, that's pi over 2, and then at 180 degrees I'll point that as pi, it would be an exact center, so and it'll be here and here. So essentially what this translates into is that when cos pi, that would be minus 1. So it'd be minus 1 times minus 5, otherwise known as 5. And then what's minus at sine pi, that would be I've drawn this kind of badly, haven't I? It would be there. It would be in the middle here. So it would be 0. So this would be 0, nothing else. I'll go and draw it as minus 0 just to be extra sure, but you should need to do it. So, and then for half pi, that half pi cos would be 0. So we have, again, we have a 0, negative something, and then 3 sine pi over 2, that's at when sine is 1. So you'd be at, it would be 3 and 3. So it's essentially 5 minus minus 3, which is 8. There we go, we've solved the integral. On the diagram in your answer booklet, shade the area represented by the integral in A. So I'll go and don't think I have a higher answer booklet on this sheet, unfortunately, which is a bit of a pain. But essentially, what you do is I'll go and make a quick and dirty one. But essentially, what you have is you have your graph, and then your function, which would do whatever. Say it was like that. You would find the bits where it was pi over 2, and then pi, which would be somewhere over here, and you'd be like, okay, well, it would be in the middle here, so I'll shade that area. They don't make this available for me online unless, well, I mean, I'm being very lazy, not, but it'll be something along those lines. Right, second last question. Express minus 2x squared minus 12x plus 7 in the form ax plus b squared plus c. So this is just completing the square. So minus 2x minus 12x plus 7. So what I always do for this one is I want to make this area here, the start equation, suitable. So I'm going to get rid of the factor of x squared. So I'm going to divide this by minus 2. So we're going to have x squared minus plus this time 6 plus 7. Okay, remember this minus 2 will come back later. So then when we want to do this, we want to turn this into just a plain x power of 1. What we can do is we can say get rid of that, and then we divide this by we'll get rid of that x and replace it with 3, but we'll divide by because we divide by 6 by 2, and then plus 7. But the important thing to notice here is that we want to get rid of the square of 3. So square of 3 would be 9, but then we multiply it by minus 2, so this would actually output 18 higher than the minus 18 lower than it should do. So we need to correct for that. So we end up with minus 2 x plus 3 squared plus 25. Oh, look at that! I've just found the what we were supposed to be looking for in the answer booklet. And I'll go on. So for this shading area, this was what you would be looking at. So you'd find the bits where you'd be pi, but you can see for 3 cos x is 0 at half pi, and then it's the lowest point at pi, so you can work it out from there. Okay, so we're on our last question now. Oh, and it's a long part, ain't it? Functions f and g are defined by fx equals 2 sine x, where 0 is in between, where x is in between 0 and half pi. G is 2x, where 0 is in between, where x is in between 0 and quarter pi. And we want to evaluate a combination. We want to evaluate a combination function, and we put of fg, and we throw in a 6 of pi. So let's go and do that. So we'll work out g first, I suppose. So gx equals 2x. So that means g of pi over 6 equals 2 times pi over 6, which is pi over 3. Then we're going to say, well, fx equals 2 sine x. So f of pi over 3 equals 2 sine pi over root 3, and then we need to use our exact value triangles, so I'm going to have to quickly draw that out. Looks like that, and then we just fill in what the numbers are. So this side is 1, this side is 2, then this side is root 3. Excuse me. And then this side would be pi over root 3, and then this side would be pi over root 6. So you see with pi over root 3, sine of it would be, so remember, sine is adjacent over hypotenuse. Sorry, opposite over hypotenuse, so it would be root 3 over 2. So we say root 3 over 2, so it would be root 3. Right, and then we need to determine an expression for this combination function here. So when we do that, I'm going to say, well, fgx, and then I'm going to say it equals f of 2x, which then equals 2 sine 2x, and there we are. It's not that horrifically complicated. All right, final ones. So, given that f of p equals 1/3, determine the exact value of sine p. So yeah, we're going to get straight into that. So if f of p equals 1/3, well, f, we know, is 2 sine x. So 2 times x, p would be 1/3. So then if we just multiply both sides by, divide both sides by 2, that will give us sine p equals 1/6. And that's, yeah, it's only 2. That's why it's a 1 marker. It's not very difficult. And then final question. Hence, determine the exact value of FGP. So, what does this mean? Well, basically, as we know that sine P equals 1/6, that means that what we want to do is, excuse me. Since this is 2 sine to 2x, it'll be essentially sine 2 times the sine p would now equal, we want to figure out what sine 2p is, right? So sine 2p equals, this is where we're going to have to pull up our old relationship sheets if I can find them. One of my many Chrome tabs. Aha, here we are. So this thing here, we can say that sine 2x is 2 times sine p times cos p. And then remember, it's 2 sine p in overall, because we're working out sine 2p, and then we'll be funneling, but because f equals, f equals 2 sine, it actually would be 2 times 2 times sine p times cos p. So i.e. 4 sine p cos p. And you have to write that, otherwise you get murdered. So we're going to have to work this out. So what is sine p? Well, we've worked this out. That's actually 1/6. So then we usually work out what cos p is. And well, so how on earth are we going to figure out cos p? Well, what we can do here is we can use right angle triangles, because sine p, it's denoting a triangle. If you imagine p is here, this angle, sine p. So remember, sine is opposite over hypotenuse. So hypotenuse is up here, so that'll be 6, and that'll be 1. Using Pythagoras, we can work out this opposite side and figure out what cos p is. So, remember, c equals a squared plus b squared. So c equals 6 squared equals 1 squared plus b squared. So 36 equals 1 squared plus b squared, which means 35 equals b squared, which means b squared is root 35. B is root 35, which means that cos, considering cos is hypotenuse, adjacent over hypotenuse, that means cos p will be root 35/6. And then we can just number crunch this. So that'll be 4/36 over root 35. And then we can divide both sides by 4 into root 35/9. And there's your final answer. And there we go. That's the entirety of the 2023 High Mathematics Paper 1. And I'll be doing Paper 2 eventually when I get around to it. So thanks for watching, folks. Good luck on your exam. And I'll see you around. Mash out.